This video is a continuation of our arithmetic chapter, and it's on fractions, adding and subtracting. So let's look at the top at a couple definitions. It says fractions with the same denominators are called like fractions. Fractions with different denominators are called unlike. Not very creative, but that's what they're called. Then we have the next definition, least common denominator, or LCD. It's the smallest positive number that's divisible by all the denominators in the list. Sometimes it's called the LCM, but you won't hear me say that. I call it the LCD. So it means that the denominators go into that number. So let's take a look. We'll start with something very simple, and that is adding and subtracting like fractions. So if you are adding fractions whose denominators are the same, all you do is add the numerators and keep the denominator. And that is obviously true with subtraction also. So for example, 2 sevenths plus 3 sevenths is 2 plus 3, 5 sevenths. They are still sevenths. They don't change. Negative 3 16x's plus 7 16x's. The denominators are alike, so I combine my numerators. Now you're going to have to use those rules for integers. A negative 3 and a positive 7 is a positive 4 over 16x, so I keep that like denominator. Now, however, I can simplify this. 4 goes into 4 once, it goes into 16 4 times, and we end up with 1 over 4x. Take special note to see that the x remains in the denominator because that's where it was to start with. Little note here, I just want to point out because it is going to come up. If we're talking about a negative fraction, there's 3 different ways to show that negative fraction. You can show the negative sign in the numerator. That's the way that I usually do it. You can show it in the denominator only. That's not very common, but technically it is correct. Or you can show it out front of the fraction. That's how my math lab does it. But they all mean the same thing. All 3 of those mean negative 2. So here we have a negative 11 eighths and a positive 6 eighths. So what I would do is move that negative up to the numerator and say I have negative 11 of the eighths and positive 6 of the eighths. So I know that my answer is going to be eighths, but I have to combine a negative 11 and a positive 6. So I have more negatives, therefore I have negative 5 eighths. Here it says subtract. Now this one you've got to be real careful with. My denominators are like, so I know that my answer will have that in the denominator. My numerators, however, are not like terms. So 3x take away 7, I can't combine them. Over on this other one, I had a negative 11 and a positive 6. I could combine that. They're both numeric terms. But here, one is a variable term, one is a constant term. So all I can do in the numerator is write 3x minus 7 and then over my denominator of 4. There's nothing else that you can do with that numerator. All right, so let's look at, as you might suspect, most of the time your fractions are not going to have common denominators, so we're going to look at when they don't. There's 2 methods for finding the LCD because you have to have a common denominator before you can add or subtract. Not when you multiply or divide, but when you add or subtract. So the first way is to write the multiples of the largest denominator, and I'm going to show you this in a minute, starting with the number itself until a multiple is common to all denominators. So I'll show you that. And the multiple found in step 1 is the LCD. All right, let's look at the next page. The second method, and again, I'm going to show you both of these, is to write the prime factorization for each denominator. And then we're going to cross cancel. So let's just do one. And I'm going to do method 1 and method 2. So what I have here is I have 11 twelfths and 7 twentieths. Now we're not going to add them, but we do want to find the common denominator for 12 and 20 because obviously they're not alike. So that if I was going to add them, I could. So what I do with method 1 is I take the largest one, 20, and I'm going to skip count by 20. So 20, 40, 60, 80, 100, I almost wrote 800, sorry, etc. And then what you want to do is you want to check and see which one of those will 12 go into. What's the smallest one? Well, 12 won't go into 20, 12 won't go into 40, but 12 does go into 60. So the LCD here is 60. It's a pretty simple way, provided that your denominator is easy to skip count by. And by the way, you don't have to pick the largest one. You could have skipped counted by the smaller one, but it's actually easier if you can do it by the larger one. But if this had been like a 19, you don't want to skip count by 19. That wouldn't be a good method unless this one was 10. And then you could skip count by 10 because that's easy and check and see what 19 goes into. So it's the one that's easy to skip count by. All right, let's look at method 2. With method 2, we're going to take the two denominators, 12 and 20, and we are going to do a factor tree. So I'm going to say 12 is 6 times 2, 6 is 3 times 2, bring down that 2. So now I'm going to write that using exponents. So the 2 is raised to the second power and then times 3. So that's the prime factorization for 12. We're now going to do the same thing with 20. That's a 4. 2, 2, and 5. So here I have 2 squared times 5 as the prime factorization. And now your LCD will represent each base. So I have to have a 2, a 3, and a 5 because those are the only bases that I have. And then the exponent on those bases is going to be the highest exponent shown. So here I have a 2 to the second power. Here I have a 2 to the second power. So I need a 2 to the second power because those are the same. 3, the only 3 I have is right here, and its exponent is 1, so that 3 is good. The only 5 I have is right here. Its exponent is 1, so that's good. So what I have is 2 squared is 4, times 5 is 20, times 3 is 60. I get the same thing I got right here using the other method. In this case, though, for sure, this method was the easier one. This one takes more time, but sometimes it's the only one you can do, as you're going to see on the next one. So let's look at another example. Example 5, it says to find the LCD of 24 and 28. Well, I don't know about you, but I'm not good at skip counting by either one of those. So if I was going to do that, I would have to skip count by 28. Well, the next one's 56, and then I'm kind of lost. And I don't know what 24 goes in. So this method is actually not a good method. So let's look at method 2. Method 2 allows me to take my two denominators, do a factor tree, 6 times 4, or 2 times 3, 2 times 2. So if I show that with with exponents, that's going to be 1, 2, 3. It's going to be 2 to the third times 3. That's my 24. 28 is going to be 4 times 7, or 2, 2, and 7, which is 2 squared times 7. And now what I said was the LCD has to represent each base. So I have to have a 2. That takes care of this one and this one. I have to have a 3. That takes care of this one. I have to have a 7. And now I have to show each base with the highest exponent shown. So on the 2's, this 2 has a 3. This 2 has a 2. I need enough to cover the most, so I need a 3. The 3 is the only one. The 7 is the only one. So those are good. So now what I have to do is figure out what that equals. Well, 2 cubed is 8. 3 times 7 is 21. 21 times 8 is 168. So my LCD here is 168. And I would have had a really hard time finding that using method 1, simply because I can't skip count by 24 or by 28. That would have been a very difficult thing. So method 2 here was really the only logical method to use. Your LCD was 168. Example 6 says find the LCD of these 3 fractions, and they have variables, which actually makes it easier. The LCD here, I don't need to go method 1, method 2. All I know is that each denominator must be represented to the highest power shown. So I need a 5 and I need an x, but the highest power of x is a 3. So my LCD is 5x cubed. All right, let's look at the next one. Example 7. I need an LCD for 7x squared and 5x cubed. So think about the LCD for 7 and 5. If you skip counted by 5 would be easier. The first number that 7 would go into is 35. And then I have to have an x, and the highest power here is a 3. So my LCD is 35x cubed in this case. So again, the variables are actually quite easy. All right, we're going to take that skill of finding the LCD and we're going to go through the steps of actually now adding unlike fractions. So rather than read those steps, let's just move to the next page and I will show you one and talk you through it. So the first one says we want to add 2/5 and 4/15. So I need the LCD for 5 and 15. Now here's a little tip. If the small denominator divides evenly into the big one, then the big one is the LCD. So underneath those fractions, I'm going to write new fractions whose LCD is 15. And then I'm going to change each of these. So what you say is, what do you do to 5 to get 15? You multiply it by 3, so you multiply that numerator by 3 also. What do you do to 15 to get 15? Nothing, so don't do anything with that numerator either, because you didn't have to do anything to the denominator. And now I have like fractions. I have 6/15 plus 4/15 equals 10/15. However, my 10/15 can be simplified. Now we're going to use the GCF. So don't get the GCF and the LCD confused. The LCD is what the denominators go into. The GCF is what goes into the denominators. So what goes into 10 and 15? 5. So we're going to divide by 5, and that gives me 2/3, which is the answer or the sum of that addition problem. Let's try another one with variables. 10 won't go into 15, so 15 is not my LCD, but I can skip count by 15 pretty easily. So 15, nope, 10 won't go in. 30, yep, 10 will go in. That's my LCD. So I go underneath. I start my new fractions showing the LCD, and I say, what do I do to 15 to get 30? Times 2. So I do that in the numerator also. 2 times 2x is 4x. What do I do to 10 to get 30? Times 3. So I multiplied that numerator by 3. Notice they were multiplied by different things. That's okay, as long as the numerator and denominator of each fraction are multiplied by the same thing. So this is 9x. So now I have 4x over 30 plus 9x over 30 is 13x over 30. So I combine my numerators and keep my common denominator. Example 3, it says to add -1/6 and +1/2. Well, 2 goes into 6, so I know that my common denominator is 6. This one is going to stay negative. What do you do to 6 to get 6? Nothing. Let me scoot this over so you can see that negative sign. It's hard to get it all on the screen at once. So that one stays the same. What do you do to 2 to get 6? Times 3. Now I have a negative 1 and a positive 3, so I have more positiveness, so that gives me 2/6. Divide by the GCF to simplify, and I get 1/3. Okay, number 4, subtract 2 minus x over 3. First thing you want to do is put that whole number over 1 so I can see my denominators. 1 goes into 3, so 3 is my denominator. The second fraction is already good. What do you do to 1 to get 3? Times 3, so we do that there. So now what I have is 3 in my denominator, but my numerator pieces are not like terms. So all I can do is write 6 minus x. Now here is a word of caution here. Do not think you can cross cancel the 3 and the 6. That numerator is a unit. It's all together, 6 minus x, and 3 doesn't go into this part, so it can't go into that part. So you just leave it like that. All right, let's look at example 5. I don't know why, but students think these are harder. These are actually easier. We have 1 over 7 minus 3 over x. I need a common denominator. Well, I know that my LCD has to represent each piece, so it needs a 7 to represent this, and it needs an x to represent that. So my common denominator is 7x. So notice what I did. I set up my fractions with that common denominator, and now I'm going to go through the same process. What do you do to 7 to get 7x? You multiply by x. So you multiply that top one by x too, and you get 1x. If you want to write the 1, that's fine. Now, go to the second fraction. What do I do to x to get 7x? It doesn't need to be multiplied by x. It already has 1. What do you do to x to get 7x? You multiply by 7. So that's what you do on the top. So again, you're not multiplying by the same thing for each fraction. Now I have a common denominator of 7x, but 1x take away 21, those aren't common terms. They're not like terms. So it's just x minus 21. And no, you can't cross cancel the x's or the 7 into the 21. Think of that numerator as a unit. If you need to put parentheses to remind yourself, do that. All right, let's look at another one that's like that. I have a 10x squared and a 15x, and I want to know the LCD. Well, I skip counted by 15. Let's look up here. I skip counted by 15 up here and found that 30 was the LCD when I had a 15 and a 10. So we're going to use that again. No sense to do it all over. We'll just use the same work we already did. So I know that the number part of my LCD is 30. Now let's look at the variable part. This one has x squared. This one has x. Well, I have to have the one that has the most. So I change them both to 30x squared, 30x squared. Now let's go through it one step at a time. What do you do to 10x squared to get 30x squared? Well, I don't need to multiply by x because I have exactly the right amount, but I do need to multiply by 3. So I do that in the numerator also. Second fraction, what do you do to 15x to get 30x squared? Well, I don't have enough x's here, so I'm going to multiply by 2x to get enough x's. So this is 2x also, giving me 14x. And once again, we have a situation where we have a common denominator, but the numerators are not like terms. So all you can do is just write them like that. Be very sure you can work this kind of problem with variables. All right, let's look at an evaluate problem. It says evaluate y minus x if x is -3/10 and y is -1/6. The thing that's hard about this is the signs. You have to be so careful. So here I'm going to take out the y and I'm going to put in its replacement, -1/6. Now I'm going to write my subtraction sign, take away. Now I'm going to put the x, which is negative 3/10. So that those negatives don't go together, I'm going to put parentheses just to separate those. Well, I know that two negatives together makes a positive. So that's the same as negative 1/6 plus 3/10. And now I just need a common denominator. So we're going to skip count by 10. 10, 6 won't go in. 20, 6 won't go in. 30, 6 goes in. So we're going to change those to fractions whose denominator is 30. This one is going to stay negative. So what do we do to 6 to get 30? Times 5. So this is negative 5. Let's make that negative a little bit bigger. And then what do we do to 10 to get 30? Times 3. So that's 3. Now I have a negative 5 and a positive 9. There's more positiveness. So I have 4/30. However, with 4/30, I can simplify by dividing by the GCF. And I end up with 2/15. And I went right off the page. 2/15. I miss having students when I do these to tell me, wait, we can't see. So just a matter of replacing the values. All right, last one has to do with perimeter. And perimeter of a rectangle is just the distance around it. There is a formula, 2 lengths and 2 widths, but it's really just as easy just to add up the sides. So I'm going to go ahead and label all the sides, and I'm going to say my perimeter is 3/8 plus 3/8. I'm going to do these two first, and then plus 2/15 plus 2/15. Then I did my 2 widths. So that's going to give me 6/8 plus 2/15, and 2/15 is 4/15. I'm going to give you a little tip. I need an LCD for 15 and 8, but I noticed that 6/8 can be simplified by dividing by 2. And if you do that first, it's going to make it easier to find the LCD, because now rather than looking for 8 and 15 common denominator, I'm looking for 4 and 15. So we're going to skip count by 15. 4 won't go in. 30, 4 won't go in. 45, 4 won't go in. 60, there we have it. So I'm going to rewrite my fraction with that denominator that I'm trying to get to. What do you do to 4 to get 60? Times 15. So here that gives me 45/60. What do you do to 15 to get 60? Times 4. That gives me 16/60. When I add those, 45 and 16 is 61/60. We're actually going to change this one to a mixed number because it makes more sense in the context of the problem. So 60 goes into 61 one time with 1/60 left over, and that label is inches.